Welcome students. Today we are doing 4.6, formalizing relations and functions. We're going to determine whether a relation is a function, and we're going to find domain and range and use function notation. In Tuesday's class, we talked a little bit about function notation. We're going to enhance that today and talk about domain and range, which is what we are going to talk about first. So you may or may not remember that when you write an ordered pair, as we have one here, the ordered pair goes in alphabetical order, X then Y. When we talk about domain and range, domain is X, range is Y. They also go in alphabetical order. Makes it easier to remember. Domain is X, range is Y. So this question says, identify the domain and range of each relation, represent the relation with a mapping diagram. Then we want to determine if the relation is a function. Okay, so we'll address all of those questions. What you have to do when you list domain and range in a function, you have to list domain and range. Two really important things you need to do when you list domain and range. First thing, you have to list it least to greatest. Okay, least to greatest, smallest to biggest, etc. And then you cannot have repeats. So if you have two x values of 2, you don't write the 2 twice. You just write it once. So no repeats. So that's a really important piece of this. I'm going to take these two sets of ordered pairs and copy them to another page. So reminder, really, really important. You could see a test quiz question coming up on Friday's quiz. Remember, Friday's quiz is 4.5 and 4.6, both. So when you list domain and range, list it least to greatest, no repeats. So we're just going to talk about domain. I just write a D with a colon there. And least to greatest, so it's already in least to greatest for the x values. Remember, domain is x values. So we go from -2 to 0 to 4 to 5. Okay, range is your y values. And range, in this case, goes from 0.5 to 2.5. Realize we have a 2.5 that repeats, so I'm only writing that one time, and 6.5. Okay, so I'm just listing domain and range for now. Once we're done with domain and range on both of these A and B examples, we'll go ahead and do the mapping diagram so you can see how that works. So domain here for B, least to greatest, we have 4, 5, and the 6 repeats, but we only write it one time. Range, in this case, we have 3, 4, 5, 8. Okay, so really important for you to understand what is a function and what is not a function at this point. So I'm going to go back to our first page here and add a little bit. So if you have repeated x's, it is not a function. Okay, no repeated x's. It does not matter at all if the y's repeat, but you cannot have a repeated x. So let's look at this. You may remember from this example, we had the x values repeat here and here. Those 6's repeat. This is not a function. If it is not a function, you do not need to do a mapping diagram. So it's not a function. Because x values repeat. Okay, so not a function because those x values repeat. Over here, to do a mapping diagram. When you do a mapping diagram, we're going to leave, let's just do it. So we're going to list domain and range. Instead of horizontally, we're going to list it vertically, up and down. So domain for this one is -2, 0, 4, and 5. And for range is 0.5. Okay, so 0.5, 2.5, and 6.5. So you may remember from the A example here that the 2.5 repeated on the y values. Again, it's okay if it repeats on the y values, not the x. It is not a function if x's repeat. If y's repeat, it does not matter. It does, however, influence our mapping diagram. So let's talk about our mapping diagram. So all we're doing with this mapping diagram is we're matching ordered pairs. So matching x values with the corresponding y value. So in a mapping diagram, we'll write that down. So mapping diagrams, couple directions. We're going to list least to greatest again. So list x and y values, least to greatest. Then we're going to match up the ordered pairs. So we're going to match x values with y values. So match x values with y values. For each ordered pair. Okay, so list it least to greatest, then match the y values and x values as they correspond with ordered pairs. So if I come back up to the top here, remember you can always pause the video if you need to catch up writing things. So if I look at the ordered pairs way up here, we have -2 goes with 0.5. So I just draw an arrow or a line in between, line straight across. -2 goes with 0.5. 0 goes with 2.5. So again, a line straight across. That won't always happen, so don't assume it will. This is the perfect case because both the 4 and the 5 go with the 6.5. So it is not, it is a function. It does not matter if the y values repeat. So I'm just going to show you the mapping diagram here. I said you don't need to do it. If you're confused about what is and what is not a function, it may help you to do a mapping diagram to determine that. So if we look here, we have 4, 5, and 6 for domain. And for range, we have 3, 4, 5, and 8. So if we go up to the order of pairs, 6 goes with 5, and 6 also goes with 4. So 6 goes with 5, and 6 goes with 4. So right away, if you got all the way to making a mapping diagram, if you see 2 lines coming from one x value, it is not a function and you can stop. So I'm just going to write a big giant not for not a function, okay? So that's how domain and range works. Again, least to greatest, no repeats. You determine whether or not it is a function. If you have repeated x's, it is not a function. Repeated y's do not matter. So we're just going to list domain and range and do another mapping diagram just to help you guys out here. So I've got 4.2. We're doing domain here. We're supposed to go least to greatest. Let me do that again. Smallest, actually it was 4.2. So the 4.2 repeats, we're only going to write it once. Then 5 and 7. Range would in this case be 0 first, then 1.5, then 2.2, then 4.8. So this one is not a function because the x values repeat. 4.2 goes with both with 1.5 and 0, so not a function. Over here, we're going to list domain and range. So domain, we have -1, -2, then -1, then 4, then 7. So if you get confused at all with negatives, it can be confusing. You saw me kind of mix up -2 and -1. -2 is smaller. You could look at a number line if that helps you, just so you don't mess that up. Range here, we go -7, that's the smallest range value, then -4, then 2, then 1. So when you do problems like this in the textbook or for me on a quiz, they're not going to give you more than 4 or 5 ordered pairs. We're not going to give you like 20 of them. Just it would be annoying. Okay. So is this a function? We only have one x for each y value. So yes, this is a function. Then we'll go ahead and do the mapping diagram. So to map, we have domain and range. You don't need domain and range up there. I just do it because it helps me keep it all straight. And then we can write down -2, -1, 4, and 7. And our range values are -7, -4, 2, and 1. So again, just like when you list domain and range horizontally, when you do a mapping diagram vertically, it still is in least to greatest order, no repeats. So you got to refer back up to the order pairs. So up here, -1 goes with +1. So -1 goes with +1. So you can see how the arrows don't always go straight across. Sometimes they go diagonally. -2 goes with +2. So -2 goes with +2. +4 goes with -4. And +7 goes with -7. So when you see different lines coming from each x value, that's another way to determine if it is or is not a function. So this one is a function, the first one is not. Okay, so we're going to talk about a vertical line test now. I'm going to show you some calculator stuff. You do not have to know. It's just nice to be able to see these things on a calculator. So I'm going to plug these into a graphing calculator. If you want to graph it, just sketch out the ordered pairs on a coordinate plane, like x, y value. It's a good idea to do so. but I'm going to open up the calculator here and do it like that, because it's good to look at this function as well, negative x squared plus 3 on a graphing calculator, just so you can see what they kind of look like. Okay, so we have x values of -4, -3, 0, -4, and 1. I have to write them in order in the graphing calculator, not how you would do it. But in the graphing calculator, that's how I have to do it. So -4, -3, 0. -4 and 1. My L2 list up here is my y values. Y values are 2, 1, -2, 2, 1, -2. So I'm entering these in as the order pairs appear in the problem. So 2, 1, -2, -1 and 2. So if you guys end up having me for junior year, when you do these graphing calculator problems, it is critically important that you're just really careful when you put these values in, otherwise you get the completely wrong answer. So now we're going to graph these. I have to do a few things here to graph, so let me just check. That's good. So I can hit graph now. And there are the ordered pairs. So when we talk about this vertical line test, let me just copy this onto the page. Make this a little smaller. Okay. So when we do this vertical line test, what we're doing is we're taking a vertical line and passing it over the function. So I'm going to make this a little bit bigger. Looking at my screen, I think it might be hard to read. So when I pass a vertical line over this function, I hit it in 2 places right here. Right, that means this x value of -1, -2, -3, -4, that x value of -4 repeats. And if I look up here to confirm, indeed, the x value of -4 does repeat. So if we take a vertical line and we pass it over the function and it hits 2 dots, or it can hit the function, it could be a curve, the function. It could hit that curve in 2 places as well. But because this hits in 2 dots, if I take a vertical line and draw that down here, so here's my vertical line, and you can see that it hits right here and right there. That's what makes this not a function. Okay, now we're going to plug in this -x squared plus 3 into the graphing calculator so we can see what that thing looks like. So we have -x squared plus 3. We'll take a look at that graph. What you guys will learn before the end of the year is that a negative in front of x squared takes a parabola U shape and turns it upside down to make it look like a mountain. So I'm going to copy that to this page as well. So if I look at this function now, and I pass my vertical line over the function, even though it gets really steep right here, and if we took this down from -10 all the way down to -1,000,000, this line would look almost straight. It never is actually straight. It ever so slightly keeps angling out here. So if we pass this vertical line, it only hits it once. Everywhere we pass it along here, start from this side, pass it along, it only hits it once. Start from the middle here, hits it once, hits it once. So this one is a function. So for whatever reason that vertical line test confuses people, hopefully it will not confuse you. Again, if it hits it twice, it's not a function. X values repeat. You can confirm it by looking at the X values. Now, if they give you a function like negative x squared plus 3, you're not going to be able to tell if X values repeat. But in this function, for every X value, there's only one corresponding Y value. Okay, so function notation. We have this equation, negative 3x plus 1. You guys would always write that as y equals. Okay, with function notation, we just simply replace that y with f of x, and it equals the same thing. I copied this because I like what they say. Notice that f of x replaces y. Just like I said, it is read f of x. Letter f is just the name of the function, not a variable. So this f is not a variable. And what I told you guys on Tuesday is that on the f of x side, never do math on the f of x side. So never do math on the f of x side of the equation. So when they say f of x, it could also be g of x, a of x, h of x, anything. The three most common letters they use, I would say, are f of x, g of x, and h of x. But again, it totally doesn't matter what that is. Your x could be a different letter as well. It just makes it easier if we use x, but we'll do some function notation problems where it's like c of d. D represents distance and c represents the cost. Okay, so we have a problem with function notation. This problem says the function w of x equals 250x represents a number of words, w of x, you can read in x minutes. How many words can you read in 8 minutes? So if we write that equation, w of x equals 250x, and all we're doing is taking this 8 right here and plugging it in for this x and this x. So remember, on the left side, no math allowed. All that this function notation is saying is if we plug in 8, what answer do we get over here? The only way to determine that is by plugging in. I meant to put the 8 here, not the x. So if we plug that in, we should get 2,000. So if we read for 8 minutes, we should be able to read 2,000 words. Okay, so how many words can you read in 8 minutes? 2,000. Doesn't get a heck of a lot easier than that, right? No worries. Let me just pull up the textbook. Give me one sec here. Just want to make sure we're good on all the homework problems. Super fast. Just doing the hard copy of the textbook too, in case this takes forever. All right, chapter 4. And 4.6. Okay. So we've done problems like 18, 19, 20, and 21 before, but let me get to an example like that. So problem 4, here's a good example. So problem 4 here asks us to find the range of a function So our function is f of x equals negative 1.5x plus 4. They give us domain values or x values of 1, 2, 3, and 4. And as we did on the quiz problem, what we're going to do is plug in 1 for both of these x's. No math allowed on the left side. So when you see a problem like this, you're really doing 4 for one problem. Okay? When we plug in 1, what do we get? Negative 1.5 times 1 plus 4 equals, I'm going to plug in 2, just kind of right in a row here, negative 1.5 times 2 plus 4. See what that one equals. And the reason I'm doing it like this is because I want you to see the pattern. Math is all about patterns. Try to find the patterns. It makes the math easier. When we plug in 3 for x, we get negative 1.5 times 3 plus 4. See what that equals. Lastly, I'm going to plug in 4. So f of 4 equals negative 1.5 times 4 plus 4. And we'll go ahead and see what that equals. Okay? So negative 1.5, I'll show you. If you have a graphing calculator, it works out well. If you have a 4-function calculator that has a back arrow, you can do this method as well. Just makes it easier on you. So if I have negative 1.5 times 1, I'm just using parentheses, plus 4. Going to double check, make sure I plugged that in correctly. Negative 1.5 times 1 plus 4. I did. So we can see what that equals. So if you have that 4 function calculator that has the 4 buttons kind of in the upper left, you can hit the back arrow and back arrow until you get to 1. And then change it to a 2 for the next problem so you don't have to type the whole thing again. So for me in the graphing calculator, I just hit second enter, and I just hit the back arrow until I have the 1, and this will overtype, as in it'll replace the 1 with whatever number I choose. We're going to do 2 next. So what is the pattern? We went from 2.5 to 1. So our first answer was 2.5. Our second answer was 1. So what happened? How do we get from 2.5 to 1? What did we subtract to get from 2.5 to 1? We subtracted what the slope is, negative 1.5. So if you think about this answer, subtracting negative 1.5, you can think in your head what we get, and I'm going to do it on the graphing calculator, and you can see if you're correct. So think in your head what you get. Give you a pause, wait time. Now we'll do it in the calculator. We plug in 3, should get negative 0.5. 1 minus 1.5 is negative 0.5. Again, the pattern. Don't forget your negative. So if we subtract 1.5 again, remember when you're subtracting 2 negatives, add them up, keep the sign. So 0.5 plus 1.5 would be 2. Keep the sign, negative 2. Then we'll double check on the calculator. Second enter, back. Plug the 4 in, and indeed we do get negative 2. Okay? So that's another kind of problem you get. You'll get a function up here. You'll plug in x values on the left. And remember, no math over here, no math on the left. Only do math here to get your answers here. So what is our range? Remember, that's a question that was asked up here. What is range? Remember, you have to list range just like we did before, least to greatest, no repeats. So we're going to do that now. So negative 2 is our smallest value, so we go in reverse order here. Negative 2, negative 0.5, 1, and 2.5. So again, list the range, least to greatest, no repeats, no math on the left, plug the values in, see what y values you get. Remember, f of x is very similar to y. It's not the exact same, but for your understanding, you can think of f of x equaling y. Okay, let's look at the homework again to see if we have a good example 5 we need to do. Yeah, we already did one like example 5, but let's do it. So this one says, we're trying to identify a reasonable domain and range. You have 3 quarts of paint to paint the trim in your house. So that's just like all the little wood edges that go around windows, and baseboards are considered trim as well. A quart of paint covers 100 feet squared. So it covers an area of 100 feet. I know it's area because it is feet squared. A function a of q. So a represents area, q represents quarts. 100q represents 100 feet that each quart paints. what is domain and range are reasonable for the function. Okay, so we'll talk about that. I'm going to start with 0. Just makes it easier for a graph because they're asking us to graph here. So I'm going to do 0, 1, 2, and 3 for my domain values. I'm going to do that by making an XY chart, or in this case, Q for quarts, and then A of Q is the area covered by those quarts. So again, if it helps you to think about the Q as the X and the A of Q as the Y, because you like that in graphing, that's fine. So if we plug in 0 to this equation, A of 0 equals 100 times 0, we get 0. 100 times 0 is 0. So that means if you're thinking about your X and Y axis, that's going to start at the origin, where X and Y cross is called the origin. The coordinates of that point are 0, 0. Then we'll plug in 1, 2, and 3. So 100 times 1 equals 100. So when I plug in 1, the area covered is 100 feet. When I plug in 2, area covered will be 200 feet. $100 times 2 is 200. I'm not going to do the 3 because clearly it's 300. So 2 gives you 200 square feet covered. 3 gives you 300 square feet covered. Again, you can always pause the video if you get behind. I'm going to copy my XY table, or in this case, my Q, A of Q table, to the next page so I can go ahead and graph it. I'm going to leave the XY above there because I think it's going to make it easier for me to understand how the graph works. Make this chart a little bit smaller. I'm going to move it over here. Then we're going to graph this thing. So the Q is the X. We're going to start at 0. I'm going to skip a line in between here just because my graph's not so bunched up then. As long as you keep that separation consistent, doesn't matter what the graph is. So we start with 0 here. I got a bunch of space here. If I go by 50s, I'd have 300 divided by 50. I've got enough spots to do that. So let's go by 50s. So we've got, I'm also skipping a line. So technically that's 25. Next one up's 50. Then 100, 150, 200, 250, 300. Important also, I know this seems kind of stupid, but check your numbers. Sometimes when I'm doing these graphs, if I've got like 3 or 4 kids talking to me at once or whatever, my mind's distracted, I might skip one by accident. So just be careful you've got all your ducks in a row, so to speak. So we have that point at 0, 0 from here. Let me move this over a little bit so it's easier to see. Okay, so I have a point at 1, 100, at 2, 200, at 3, 300. And if I were to do 4, I'd have 400. Because 400, I went too far, I think. That works. Okay, so let's draw the line. Okay, so there's our graph. It is a linear equation. We're not squaring the x value, or in this case, the q value. That's what makes a curve. If you think about our last graph, that negative x cubed plus 3, that had a curve. This is linear because the x value, or in this case, the q value, is not multiplied. Now I'm going to go back and make sure I answered the question. It asked me what a reasonable graph was. And then I think it asked me what a reasonable domain and range was. What domain and range are reasonable for the function? What is the graph of the function? So what domain and range is reasonable? Any positive chord value is reasonable. Now I say that with a grain of salt, right? Because you're not going to buy 1 million quarts of paint because the store won't stock that much and your house isn't that big. But I would say from like 0 to 10 quarts is a reasonable domain value. So domain, I'm still in the line tool. From 0 to 10 quarts, it's reasonable because I'm probably not going to have more than 1,000 square feet of trim. That's a ton of trim. And then the range, again, we're going to have positive values. If we went up to 10 quarts, we'd have 1,000 over here in the area that it would cover. So we could say the same thing, 0 to 10 for the range, or 0 to 1,000 rather. For the range, I don't think you'd have more than 1,000 square feet to cover. All right, so I saw another question here, which helped me to realize I forgot to put 2 examples on there. My smartboard was going to freeze on me there, but it's good. It says if you have 7 quarts of paint, what domain and range are reasonable for problem 5? So if you have 7 quarts of paint, from 0 to 7 would be reasonable with quarts. You don't have the 8th quart, so you can't do it. But 0 to 7 works for that. Why does it not make sense to have domain or quart values less than 0? Well, you can't paint with negative quarts of paint. Simple as that. All right, that's all I have. We are on slide 10 of 10. Good luck with the homework. We'll talk with homework questions tomorrow. The homework will be posted on Schoology. Important that you guys are trying each and every problem on the homework. I have kids that are putting question marks by certain problems in the homework. I post solutions. Take advantage of those solutions. I recommend you have the solutions open. Book page, solutions open, so that if you get stuck on the book page, you can then look at the solutions to help you figure it out. All right? We will see you all on Friday. Be ready for your 4.5, 4.6 quiz towards the end of class. That is it. Have a fantastic day. I'm off to go mountain biking.